Actually, hello. How how can we judge that we should apply the geometric formula or Poisson or binomial or whatever? Is there any tricks or easy rules or algorithm type of rules or protocols? Actually, I am totally
No,
confused
no.
about all these formulas.
See, if you find range, you will get some idea what the distribution might be. See, if the range, if your random variable can take 0, then definitely it will not be geometric. Correct?
Yes. Yes.
Geometric
Sir,
starts with 1.
please repeat again.
See, what am I saying is, if you can able to find, if it is discrete, if you can able
Yes,
to find the range of your random variable, range, you
yes,
understand range, right? What is range?
yes,
Ah,
yes.
ah. So from range, you can somewhat guess. You can't guess the exact distribution, but you can eliminate few things. So if your range has 0 in it, then it will not be geometric because geometric starts from 1. Okay. If
Okay,
your range is starting from 1 and it is having integers only like 1, 2, 3, 4, and so on, there is a high chance of it being a geometric, because if it
okay,
has to be Poisson, then 0 must also be included in your range. If there is no 0, then it is not Poisson. Like this, from range you can somewhat eliminate few distributions, common distributions, but there are no algorithms, direct algorithms to say, because
actually, the problem given in the question that by analyzing the problem, we have to decide. No other way.
no other way. See, distributions, depending upon the data, we have to find what distribution it is.
Actually, sir, even I was struggling, but now I gained some confidence.
Mm-hmm.
Okay, sir, one request from my side that before quiz 2, please, in the revision session, please solve few questions like one by one. This one is for binomial, this one is for geometric Poisson. Then it will be easy to understand for the strugglers.
Okay.
This
Okay.
2 weeks once, the revision session also very helpful, sir.
Yeah. We will be having that every 2 weeks. Okay.
Good evening, sir.
We will be continuing this. Yeah. Good evening, Lakshmi Padmaja, right?
Yes, ma'am. Yes, sir.
Yeah.
Yeah, we had our math session, sir.
Okay. Okay. So how was the paper, Miss Lakshmi Padmaja?
I felt it was a bit lengthy, sir.
Bit lengthy. Okay.
Yes, sir. Actually, that is time management. I think so. It is for me. I don't know how for others.
Okay.
Maybe.
Okay. So most of the comments are bit. Yeah. Smile.
How about others, sir?
Good.
Sir,
Yeah. Most of them are saying it is difficult.
I started with Stat 2 in
Hmm.
quiz 1. I started with Stat 2
Hmm.
and I was able to complete it and even recheck it, all the questions again. So,
Within 1 hour, is it?
yeah, yes, sir.
Hmm.
No, I
Less
have
than 1
math
hour,
and stats, sir.
basically. I
Okay.
completed the exam in like 45 minutes only.
So there was a session that
I really like the game, sir. Like most of the questions were like clubbed together, so 2-3 questions were in series, right?
Yeah.
So they are connected.
Yeah.
So that is
Yes.
that really saves a whole lot of time, sir.
Yeah. So
But
that
the
is how
I
disadvantage,
really like that.
first question, if you make wrong, maths also
Three
like
will
that.
go. All the three will go.
Training questions was there. Maths, what
That
happened
is true,
was,
correct also.
yeah, first question went wrong, so almost I lost a lot of marks in maths.
Sir, I lost 2 questions in just
Okay, I'll
one-
just scroll
2
one by one
decimals
question.
with 2 decimals difference.
Oh, maybe it falls within the range, I guess.
No, sir. Outside the range, I made.
Outside
How
the
I
range,
made the
okay.
mistake, I don't know, sir. I would see.
Okay, see, first question, I hope everyone will be able to do, because we have discussed this in revision also. So if a joint PMF table is given to us,
Yeah, it's easy on this.
yeah, there are few conditions, right? You have to add A.
Discuss mock today or
No. We will start week 6. I'm just, for the first half an hour, I'll just go through this paper.
Sir, will it be uploaded in the portal?
See, one problem is again recording is not being started. I am just recording this session and I will make it available after. Okay. The session. Okay.
So there was a session that was scheduled with Andrew sir. What happened with that?
Huh?
So there was a session that was scheduled with Andrew sir. What happened with that?
Before Diwali, right? 23rd.
No, sir. Andrew sir.
Andrew sir, see that Friday session, Andrew sir has to join, but he has some other work, so he was unable to join at the time. But for the next mock, he said he will definitely join. Okay. Okay. Just be patient for some 5-10 minutes. We will just go through the paper and let's analyze what would have been better approach. Okay. So this thing, first question, I don't see any problem because there are two conditions for this joint PMF table. If you add all the values, you should get 1. And also the rows, if added, it should be equal to 1/4. Columns added, it should be equal to 1/3, 1/2, 1/6, like this. Okay, so A plus 1/4 should be 1/3. From here you will get A. From 1/8 plus B will be half. You will get B.
Equal to 1/2.
And then this, A value, A plus 1/8 plus C will be 1/4. From there you will get C. And finally you can get D. So after you do that, you will get something like this. C value will be 1/24 and D value is 1/8. So if you are instead of doing all this, if you are good enough to find this thing, so you see 1/3 times 3/4 is 1/4, and 1/8, 1/2 times 1/4 is 1/8. So if you can think of like that, you will get these as say independent.
But sir, I'm not sure it is independent, right? At this moment, we are not sure they will be independent, right?
At this
holding for some column, it does not imply it will hold for.
I have done research on this. Let me tell you one thing. If it is a 2x2 table, 2x2, just 2x2, even if you check for one, even if it is true for one particular case out of 4 possible cases, even if it is true for one case, the other 3 will definitely hold the independence condition. So you can check it for yourself. Not only 2x2.
Sir, can you please repeat, sir?
Repeat that line, sir.
So what am I saying is, for a 2x2 table, 2x2, if X is Bernoulli and Y is Bernoulli, then we will have joint PMF table and there will be 4 values inside it. Then if one case satisfies the independence condition, so if 0 case is being set, okay, let me share it and write it neatly.
Sir, 4 case means 4 unknowns, is it?
Not 4 unknowns.
4 entries.
4 entries.
So we are doing this for Bernoulli or general?
General. Any joint PMF table, the time complexity for checking the independence is not n square. So if it is n cross n table,
it is same for 3x3 and 4x4.
Yeah, let me tell that. So what am I saying is, if it is a 2x2 table, okay, so if your entries are, let me say fxy of 0, 0 only. Okay, this is fxy of 0, 0, right? And this will be fx of 0 and this is fy of 0. For suppose, what am I saying is, if for suppose this fxy of 0, 0 is happen to be fx of 0 times fy of 0, okay, then what follows is this.
Is there a reason for it? Like,
I will prove it. If you want, I will prove it.
Yes,
sir,
sir.
The pivot value is 0, 0, sir. Or anything we can take.
this one. See, if the table is given and if it is asked for are these two independent, okay, now you have checked for first entry. So how will you check for this entry? The product of marginal should be equal to this value, right?
Correct.
So if you have checked and this is being equal.
That is what, sir. My question is, if you check 0, this 0, 0 is what we have to check, or
any entry,
or any entry, not only 0, 0. So I have taken one entry. So one entry happened to be like this. Then all other entries
follows.
Okay. So the reverse also true, sir. If one entry is not independent, then
that is anyway true, right? If
no, that is correct. Means to say, then all the other 3 entries will also be non-independent.
No. That is not. That may not be the case. For a 2 cross 2, it will be. For a 2 cross 2, it will be. So just follow me. So this and finally this will follow. So you just see what I have, what we know, this we know. This is true. Okay, from here, let me do one thing. What is Fy of 0? This is Fxy of 0, 0 plus Fxy of 0, 1, 0. Correct?
Yes, sir.
So this Fy of 0 is sum of these two. So this is Fxy of 1, 0. This is Fxy of 0, 1. This is Fxy of 1, 1.
Yes,
so Fy of 0 is
follow. Yes, sir.
Fy of 0 is, I have to prove Fxy of 1, 0 is Fy of 0 times Fy of 1. Sorry, Fx of 1. Correct? Now Fy of 0 is sum of these two. So write it down. And I know Fx of 0, 0 is this. One, 0. This is Fy of 0. From here, look at Fxy of 1, 0. This will be Fy of 0 minus Fx of 0 times Fy of 0. If I take Fy of 0 common, it will be 1 minus Fx of 0. So what is 1 minus of Fx of 0? So this will be 1.
Fx of 1.
Fx of 0 plus Fx of 1 is 1. So 1 minus Fx of 0 will be Fx of 1. So this will be Fy of 0 times Fx of 1. So you see Fxy of 1, 0 is actually product of marginals. Okay, so this also holds. Like this, take these two now. Fx of 0 is sum of these two. Okay, check for Fx of 0. So this will be Fxy of 0, 0 plus Fxy of 0, 1. And you know Fxy of 0, 0 is Fx0 times Fy0 plus Fxy of 0, 1. If I want this, Fxy of 0, 1 is equals to Fx of 0 minus Fx of 0 times Fy of 0. Okay. If I take out Fx of 0 common, 1 minus Fy of 0, that will be Fy of 1. You can check Fy of 0, Fy of 1. So if I add these two, it will be 1. So if 1 minus Fy of 0 is Fy of 1. So from here, what we got? The joint is product of marginal.
Yes, sir.
And the last one will also follow.
Yes, sir. Similarly.
Yeah, similarly you can check. You can check for this. It will. Okay. So the time complexity for this 2 cross 2 table is you no need to check all the 4 values.
It is only 1, sir.
If it is true for one entry, then other 3 entries will also follow. So now what you have to do is you go back to week 1 or week 2 Just open your joint PMF tables and check there. So if 1 is being satisfied, what are the other values? You just put the constants here, and you can directly get the values. Put the constants and take only one value, and you just check. Okay. For a 3x3, this is for 2x2. What if for a 3x3?
Yes.
For a 3x3, what you have to do is you have to check this. 4 values is enough. So other 5 will follow.
Sir, this order.
Yes, sir. It's the same method.
Order doesn't matter. So you have to check for 4. So that
any 4, if it is independent, then rest will be independent.
You have to pick independent, not like all the 3 here and other one here. It shouldn't be like that. So any 2 in one row,
Sir,
any 2 in
basically we can skip 1 column and 1 row.
1 column and 1 row, one value.
And sir, if we have 4x4, then we can skip 2 column and 2 row, right?
As of now, see, this is not the optimal.
1 column there.
See, this is
1 column and 1 row there also.
This is basically n minus 1 square columns you have to check, n minus 1 entries you have to check. But this is not the optimal thing. N log n will be the optimal thing, but you don't need that. So we are not going to go beyond 3. So you don't need to worry about what is happening for larger values. Okay. So this is a good observation. So this observation I should have thought about this before quiz.
Yes, sir.
But after quiz, I was.
But it's okay, sir. It will also come in the end term exam and other quizzes also. Right?
See, someday, 2 days back only, I was just sitting and just seeing my notes.
Good tip actually.
Yeah.
So 2x2, so 1, if 1 is not independent, then everything will be not independent, correct?
Everything will be not independent.
Okay.
So that is how you can do. Let's come back. It's already. What question you want basically in quiz? So I don't think first one is difficult. What about the second one? X and Y are 2 independent Bernoullis. Easy only, right?
It's okay, sir.
So you can write the table form only directly.
Yes, sir.
And this covariance?
This is also okay.
This is also easy, sir.
Easy?
It's formula. Yes,
Yeah.
We have done it in the class, right?
I have done it in the class.
Yes,
I have,
sir.
I have just
Revision,
changed the
revision
values.
class. Yes, sir. We did covariance.
And what about the fourth one?
Markov is easy.
Markov, Poisson, easy?
Yes, sir. This also we have done.
Sir,
You also coached us about that.
This greater and greater than or equal to, I have emphasized this on revision session.
Yes, sir,
this is the first thing that I checked in the question.
Okay. And this, so someone asked Smile, I guess. He has asked.
Yes,
this.
sir.
Yeah. So that is why I said I will not answer this question. You just think of this.
Yes, sir. I ticked it quite. I still had to think about it in the exam. I reviewed it and again and again, but I think I marked the B only.
Okay, fine. So 5 questions we made it. So this is like easy questions, and next 5 will take some time to.
So this
was very tricky, sir. But
okay, so this is the question you guys are asking, is it?
No, sir.
No, sir.
Last one. Sir.
Okay, this is doable, right? It just requires some maybe slightly trickier. That's it. Yeah. So you just have to understand what is Y basically.
Yes, sir.
Yes, sir.
That
By
requires
definition, it is everything comes out on its own.
Not for doing.
Yeah. So this is doable. And yeah, this is also doable, I guess. Probability that X greater than or equals to 1 given Y is.
Yes, sir.
And this one, die.
Yes, sir. I was able to like put some values and check that this is the CDF. I calculated.
Even I did the same.
See, that thing you can
somewhere
do.
I missed it, sir. Even I tried with the numbers.
I was not able to find the journal one.
Hello, sir.
I find.
Hello, sir. Can you explain Px greater than equal to 1 given that y is equal to 2?
See, what is probability that what is given y is equals to 2?
Yes, I attempt the question. I made the joint PMF table, but the second question I have doubt.
See, I'm not discussing about table or anything. What is y? See, if you understand y properly, there is no need of computing.
So
See,
from
y
the
is
table we can do
basically
it. No, if the table is found, we do not have to even look at the definition of y.
If you found the table, you no need to go back. But if you don't know table, first part also.
From the table, I just found the value, but I
Okay.
am not sure. That's
Okay.
why. If
See,
you calculate, then
let me explain you. Firstly, easy way. Let's go. Then let's see the table and let's compute using the formulas of conditional probability. Okay. So you see, when
I
will
thought
y
that
take
it is correct.
when will y take value to?
Hello.
Both are head.
No, it's not both are head.
No. Second time head, sir.
Second time.
TH.
Second time.
TH, sir.
So when y is being 2, you know the outcomes, both the outcomes.
Yes, sir.
So the first outcome is tail and the second outcome is head. Correct? Then only y takes value 2. Correct? We have given that y is 2.
Yes.
Okay.
Actually, from the table, I should find out x greater than equal to 1. That means 1 and 2 and y is equal to 2. This is my question. From this table, if this is the table, then the answer will be...
This will be the table, right? You will get option C.
Yes. The answer will be 0.
Why answer will be 0?
One.
Okay, firstly understand
Answer
in
will be
this
one,
way,
I think.
brother. Just forget about the table, okay? Y is 2 means first one is tail and second one is head. Yes or no? Y taking value 2. Yes, right?
Yes, y taking value 2. That means the row is fixed, but y is equal to 2. And the column is 1 and 2.
Okay.
Then we find the intersection, common area, and we just add the probability. This is the process, no?
Okay. Then I will explain you in your way only. You want x greater than or equals to 1 given y is equals to 2, right? So when this will happen, this is conditional probability. So conditional probability will be joint divided by marginal.
Joint by marginal. That means we have divided by y is equal to 2.
2. So what is probability that y is equals to 2?
1 by 4 plus 1 by 4. That means half.
So y is equals to 2 is 1 by 4?
No, 1 by 4 plus 0. If the answer is C, then 1 by 4 plus 0.
Not if the answer is C. See, okay.
Yes.
Yes, sir. That's C only.
It's C only.
That we have to establish first.
So if the answer is C, look at here. Now it is given that y is 2. Okay.
That means 0 plus 1 by 4 plus 0.
Plus 0. So probability that y is being 2 is 1 by 4. Okay. Now, what is the probability that x is greater than or equals to 1, comma y is equals to 2? That means these two entries.
Yes, sir.
So
1 by 4.
X is being
1 by 4.
1 by 4. 1 by 4 divided by 1 by 4.
That is 1.
1.
Okay.
So like that you can do, or else simply when y is 2, that means outcomes are tail and head. So
I just want to clear my doubts that this is the process.
That is the process.
Okay.
And simply x means number of heads.
Yes, sir.
So when y is 2, second one is actually head. So x will always be greater than or equals to 1. So the probability will be 1. So from there also. Okay, let's discuss this thing. So here a fair die is thrown 3 times. Okay. And x1 represents the number obtained in the first throw. x2 is the second. x3 is the third. Now all the 3 throws are independent. Okay. And what is the new random variable x is defined? X is defined as max of x1 comma x2 comma x3. Now we want the CDF. Correct? So maybe whenever we have given max or min, that is where the confusion arises, I guess. So our random variable is defined to be max of I want fx of x. Correct? So fx of x is basically probability that x is less than or equals to x. And what is this x? Max of x1, x2, x3 should be less than. So if the maximum to be less than or equals to x, all x1, x2, x3 should be less than or equals to x.
Yes, sir.
When will the maximum be less than or equals to x?
When all are less than.
When all are less than or equals to x, then the maximum will also be less than or equals to x. So that means it is x1 less than x, x2 less than x, and x3 less than x. Now it is given that x1, x2, x3 are independent. So I can split the joint into product of marginals. So this is IIDs, okay, IID guess.
Yes. Now it's breaking.
Okay. So now understand what are x1, x2. So x1 as well as x2, x3 follows
Uniform
1, 2, 6. Correct? So they all follows the same distribution and they all are independent. So they are IIDs. So if you understand this, then everything can be taken as whole cube. So everything x2, x3 can also be replaced by x1. So this thing we have to find. So x1 follows uniform 1, 2, 6. Can we find the PDF of it, CDF of it?
Yes, sir.
Yes or no? So we have seen that,
Yes,
right? A fair die is thrown and what is the CDF of it? So from there you will get k by 6. So if I have to do that, I can do. Sorry, x by 6. If I take k, it will be k by 6.
I made such a blunder over here. I had reached till here and then I further started to find its CDF.
Yes, sir.
I summed all the possible max. That it could be 1, 2, 3, 5, 6.
But I calculated fx of 2.
Till here I had gotten an actually complicated lines.
Okay.
CDF for value 2 I tried to find. That
from there also, if you substitute the values, you will get
I
it.
just checked it. Yes.
So like this it will be.
There was a trick out of the 4 options given. Only one was giving answer as 1 for 6.
6.
Out of the 4 options.
Even that also works. See, that is what they are just your what you say shortcuts.
Yes, sir. 6 for 6 by 6 is
Smartness.
given 1. So that is how I chose.
Good.
What you
First
did?
option also gives 1, right?
This question also be solved with using probability concept. I think what is the chances of being 1, 4, 2, 1, 3 and 4. So by that concept also it can be solved.
You can
using purely probability concept.
see that is where the time comes into the picture. If you had solved in this way, it might have taken you some 5 to 6 minutes.
From these concepts we are able to solve, but the surety is not there most of the time.
What is there? What is not there?
Surety is that certainty is not there. That we might have made some mistakes, but this is a process that we can follow, right?
So you can see here. So our fx of x will be like this. So if I wanted to generalize, it will be x by 6.
No, sir, not 1 by 6, sir.
No.
1 by 6 cube, na, sir.
Okay, I will just yeah.
Cube. Yeah, it will be cube. All will be cube.
It will be cube. This is just the one x1
Okay.
ka
FX1.
CDF.
Yeah.
FX1 CDF, and there will be 2 more rows. Like this. So it will be x by 6 or k by 6, and it will be whole cube because there are 3. Okay. So this is the doubt, right? Everyone having the fair die thing.
No, sir. This is
not.
Last question.
Acha, last one, variance and okay. And the next thing is easy, I guess. Probability that x is equals to 5. You can do fx of 5. So just substitute 5 and 4. You just substitute fx of 5 minus fx of 4. You will get probability that x is equal to 5. What about this, Aman? Aman, easy?
Yes.
Okay, I will just mute Smile. So there is some background noise, it seems, Smile. So just please be on mute. Okay. So Aman thing, I don't think it is that difficult. You just have to make that joint table. So once you can get that joint table, it is very easy. Or else it's basic probability questions. They are just the conditional probabilities being asked. You can calculate it. And what about this fourth one? Were you able to get the values of A, B?
Yeah,
so even this thing we discussed.
Yes, sir.
In order to be a valid PDF. So I have made it in the my PDF.
Yes,
Last
sir.
questions I have given 2 questions.
Yes, sir, but hint is not given, sir, for integration. In the previous papers and all, hint was given, sir, to integrate.
Achha.
So I missed in the part of integration, sir. I interchanged the values.
Oh, yeah.
Yes, sir. Yes, sir.
So you should have give the marks to us, sir, whoever don't know the
Actually,
integration
I also
part.
struggled integration.
Because I thought sure it will be given, sir. So I didn't concentrate on integration much. So I tried.
Okay.
At the end, I got a different value. I mean the swap value, sir.
Yes, sir. Even I stuck on that part.
Based on that, the second question also got wrong, sir. Followed question also got wrong.
Actually, even I struggled, sir.
Sir, is it a x cube minus a, sir?
X.
If we integrate, first I will multiply that a x square, a x cube.
This will be x cube minus x, right?
A x cube minus x, yes, sir.
Ax cube minus
do we need to
ax.
integrate 1 by b, sir? Because it is in the range of -1 to 0, and in PDF we shouldn't concentrate on -1. This should start from 0 to 1. So I just leave that part. But anyway, the answer was wrong, sir. Because of that hint, I don't. But when I practiced, I used with
Who
hint.
said we shouldn't concentrate -1 to 0?
No,
See,
it's
your
It should add up to 1. All of them add. It should add up to 1.
Yeah, we should add. But anyway, the integration part becomes 0. I'm asking, sir. That one for -1 to 0.
No, it will not be 0.
Derivative is 0.
Okay.
Integration is 1. X.
Integration
So it will be 1 by 4.
It's 1 by b dx integration. Now 1 by b will come out and dx integration will be x. And then you will put up the values in x.
That's what, sir. I tried many ways, but both questions got wrong.
Oh.
So in second question, if you integrate from -1 to -half, it would be easy. And then subtract it to 1.
Yeah. See,
another thing, sir. X cube minus x is negative in the interval 0 to 1, sir. So A should be negative to make density positive.
In 0 to 1, x cube minus x is negative, that is one good observation. So if you know the graphs of x cube and x, then x cube will be less than x in the interval 0 to 1. So our density function should be always positive. So this term negative means A should also be negative so that the product will be positive. So from there, A and D options you can eliminate directly. So that is one other. Yeah, I'm just saying, right? So if you know the standard approaches, you will complete in 1 hour. So if you haven't followed the standard approach, and if you are using the trial and error method or substituting methods, it might take you more than 1 hour. If you are using some tricks which you know, it will take less than 1 hour.
But still, sir, like integration was also like the same integration that we have done in the class only. One
Class
time.
also.
X
Yeah,
to power
that
n
x
divided
power
by
n,
plus
right? X power n.
Yeah.
Mm-hmm.
The same one has been gone through all the questions. Nothing complex has come up till now.
Mm-hmm. This question, is it? Suppose a fair die is rolled, x and y be defined as. So for this problem, what you have to do is you have to draw the joint PMF table first of all.
Yes.
From there you can get, or else you just write the table. So what is given? X takes value 1 if the number is odd, and x takes value 0 otherwise. And y takes value 1 if the number is prime, and y takes value 0 otherwise. Okay. So let me finish this one question and we will move to week 6. Week 6 we have 3-4 concepts to be discussed, and one major concept is how to find the limits of double integral. So that we will emphasize more, and we will also discuss the joint density, marginal and conditional with examples. Okay. So what is x given? X takes values 1 and 0 if outcome is
odd
otherwise, and y is 1 if it is prime, 0 otherwise. Okay, so I'll just draw this. Zero, 1, 0, 1. So this entry is basically, this entry means x is even and also it is composite.
Yes.
So as it is fair die is being rolled, our outcomes are, you just write the range first. Range of our experiment is 1, 2, 3, 4, 5, 6. Correct. So out of these outcomes, how many outcomes are, what is the probability that the outcome is even
0,
as well as composite?
Even and
4 and 6.
4 and 6.
Yes.
So out of these 6 possible outcomes, there are 2
2 by
possible
6.
outcomes. So what is the probability that the outcome is even as well as composite?
2 by
It
6.
will be 2 by 6. So possible outcomes divided by total number of outcomes. Similarly, what is the second one? Second one is x is being 1 means x is being odd, and y taking value 0 means it is composite.
Yes, sir. Odd and composite.
1.
Odd and composite. So
no, sir, not composite, not prime, sir.
Not prime. Sorry. Otherwise. So
yes.
This is otherwise case, right?
Yes.
So otherwise case is
1.
It should be odd and it should not be prime. So how many possible outcomes are there? Only 1. So 1 is odd.
Yes.
And it is not prime. So 1 by 6. And here it will be x is not odd. X should not be odd. And it should not be prime. It is prime. So even
prime. Prime, sir.
So it should be even and prime.
2.
Only 2.
Only 2. So that means 1 by 6. And finally it is x is odd and as well as it is prime. So the remaining cases, odd and prime, 3 and 5. 2 by 6. So this is the joint table. So you can write fy of y. Marginals also you can compute once you know the joint.
So now I can compute.
So this is half. You can compute, right? Half.
Yes, sir.
Half. And this will be 1. So from here, you can compute expected value of xy and then variance of xy.
Yes.
Okay. Yeah, this is how you can do. So overall, whatever I heard from you guys is paper was bit lengthy in terms of time.
Yes, sir.
But all the questions are doable. So there is nothing like few questions you haven't seen at all. Am I correct? Like you have seen
No, sir,
somewhere.
no, sir.
Yes, sir.
All the
Yes, sir,
questions.
questions
Sir,
are able to do, sir, but it's required time.
I will mark it even easy, sir. Less than like moderate, not difficult at all.
Okay.
All the questions we have discussed in the class, if someone has attended the class, he can do.
Sir, actually, in this I took 1 as also prime. Sir.
1 is not prime, right?
No. 1 is never prime.
2.
1 is neither prime nor
Not prime.
composite.
It will not affect the. It will not affect the calculation, I think.
It will.
It will not affect the. It will not affect the calculation.
If you consider it
odd, na? It is odd, na?
Then it
So here the values will change.
So, but that does not affect the calculation because it consists as 0. It is so if you take xy is 1 only for the 4th compartment.
If you take 1 as
see that
prime,
4th compartment
then it will
only
impact.
change, right? The 4th compartment will change to 3/6.
And we cannot do that. The sum should be 1.
But
Right?
but 1 is not a prime. So as we expect that you have done max 1, in max 1 we would have emphasized this. 1 is neither prime nor composite.
I even checked the
Fourth
max.
compartment is even and okay. It's
No. 4th compartment is odd and prime.
Odd and prime, yes.
Yeah. Okay. So that is about quiz 1. So I have noted down your feedback. We will let Andrew sir know this. And
sir,
maybe we will be much more careful in quiz 2.
No,
No, sir,
does
we
this mean
have
next
lots
time the
of
paper
tips
will be
and
difficult?
One by one. I'm just
No,
lost
sir,
in
just
between.
asking like, does this mean that next time the paper would be difficult?
Next time the paper would be difficult. No.
You were asking for the feedback.
No. We will not do like that. I'm just asking the feedback because see, before the exam, we will know only our side feedback. So whatever feedback Andrew sir gives or whatever feedback we has, so we expect students should be able to do this, that, and we will have some predictions, right? And after exam, we will get to know what is actually happened. So that is what we need, and we will just compare, are our predictions correct? So do we have to go like this or do we have to change anything? So that is right. See, even this is data. We collect each and every feedback is a data to us, and depending upon the data, we change our module. We modify our module.
Sir,
we need lots of tips
Tips
do
for
it
exams, is it?
Yes. Okay, how to solve fastly this type of
We need to do more number of questions, I guess, sir.
That is one way.
Yes, sir.
And the other way is you just have to understand the question clearly. So what is?
Yes, sir. That's what I told, sir.
They're
Because,
asking. So you have to
to
be in
understand
our-
the question, it took a lot of time than
Yeah,
doing
yeah.
the sum, actually. Yeah. So,
And
and once, twice, I
before
kept
the
on
exam
thinking.
only, I already suggested these things. You have to be in our foot and you should think. So what kind of questions can be asked? So you should have to think. So can a question come from Markov inequality or can a question come from Chebyshev inequality? If it comes, how will the question be? How might be the question be? So you have to, these all things you have to do before the exam only. Not 1 day or 2 days before the exam. You have to
Yes,
do.
sir, that's true, sir.
1 day and 2 days before the exam, you should only focus, practice the main things, important concepts. By then, the revision sessions would have also be completed. Just go through the revision sessions, your notes, and also
Only
I suggest
short
you
notes are enough, sir. If we have done everything, so short notes we have to go through.
So these notes and everything will be helpful. Okay, during the revision sessions, we will discuss a few tips also. So, tips
There's
means.
also
Yeah.
there's something else I also felt that we get these extra activities, which is the applied part of what we're learning. I mean, identifying the random variable, continuous, discrete, and all that, which is really helpful. But the problem is sometimes we struggle. We collect some data and we're just not able to, even identify which one is discrete and which one is continuous. And if it is continuous, how to convert it into a discrete variable? How do you change the data set? So, for example, in our last activity, I was not able to submit because I was stuck. The data I had collected was not matching up to a discrete random variable. None of them seemed discrete. So I decided to collect more data, a separate set of data. I collected it, but because the quiz was, around the corner, I could not focus more on that. I just dropped the whole idea of submitting the extra activity. And yet I know it would have been a good learning for me.
Yeah, same here.
So that continuous one you can submit in this week.
Continuous one?
This week activity involves this continuous random.
Continuous thing, yeah.
Yeah, and I don't know if I'll be able to know how to go about checking whether it's continuous, whether it fits in a continuous distribution or not.
So regarding that activity, sir, actually I collected data on number of visitors on a website. And obviously it's it was in a range of like 200 to 2000. Okay. So I wanted to make it something like very discrete. So what I did is I defined like my binomial random variable as if it is above 400, then it is success, and otherwise it is failure. I want my visitors to be more than 400. And that is how counted it. So is that approach like good or okay? I mean, is it acceptable?
It was okay. It is acceptable, but you can come up with a better distribution. When you say number of people coming to a website or coming into a store, so when your random variable is dependent on time, so during the time, Poisson would be a better fit than binomial.
Poisson was not fitting it, sir. So what I did is I counted the number of days on which I will get like more than 400 visitors. And
okay.
Yeah.
Oh, you are counting it.
Binomial random variable it becomes,
okay.
Sir, if you define
success. Yeah. Okay. So, even that is good.
Yes.
Okay. So let us come back and discuss week 6. Let's leave the quiz apart. As you have given your exam, just wait for the result. I hope result should be on your positive side. And in between, we will try to do week 6 because week 6 deadline is on Friday. And for week 6, you are going to have only 2 sessions. One is today's and another one is solve with us. Okay. And week 6 also, the main difficulty is how to find the double integral limits. So from the past experience of past students, we got this feedback that in week 6, everything is okay, but finding this limits for the double integrals is a little bit difficult. So we will discuss that in this today's session. And then on solve with us session, maybe 1 hour or 1.5 hours, we will try to solve problems. And the last half an hour or 1 hour, we will again convert it into an open session. If you have any doubts, we can discuss it on that day. And that session is on Friday, so same deadline day only. My suggestion is you just go through the week 6 contents as early as possible. And on Friday, please be ready with your doubts. Not like you don't sit like you haven't watched the lectures on Friday also. Don't be like that. So watch all the lectures and try to understand, try to solve all the tutorial questions. After this session, you have 2 days, right? Wednesday and Thursday and Friday, 3 days. So within these 3 days, try to watch the lectures and try to solve the problems in activity. We will do some problems here. So look at how we solved in this today's session, and then you will be able to solve the activity questions also. And then do practice tutorials also, and come to the solve with us. Do graded also. So before coming to the graded solve with us, do graded also, and then come to solve with us session, so that we can somewhat skip that solve with us session, and we will more of focus on doubts on that day. Okay. Okay, chalo. We will start.
Yes, sir.
So week 6 is basically about continuous random variables ka joint distribution. So we started from week 1. Week 1 we have seen joint distribution between two random variables which are discrete. And slowly what we have seen is between discrete and continuous in week 5. So what if one random variable is discrete and another random variable is continuous? How will the joint distribution looks like and how to compute the probabilities we have seen in week 5. Now in week 6 what happens is slowly this discrete part goes off, and between two continuous random variables, how will the joint distribution be? So if there are two random variables x and y, how will be the joint distribution between x and y? So that we will see. For that we need this joint density. So we should understand what is this joint density means, and then we will see 2D uniform distribution. If it is 2D uniform distribution, how to compute the probabilities, or how will the joint density be? And we will also see 2D non-uniform problem also. So uniform we can compute easily. What if it is non-uniform? In that non-uniform itself, we will try to find the limits, how to compute the limits. So if you have gone through the lectures, you will be seeing that it will be double integral some fxy of x comma y dx dy. So how to compute these integrals? So how to compute integrals? So will it be one after the other, or you have to compute it whole? We will see that. And also there will be limits for these integrals. So even how to find these limits, from where to where we have to integrate, we will see that. And then after that, we will look at marginal density, independence, conditional. Everything is of discrete only. So there it is marginal probabilities, conditional probabilities, independence between two random variables which are discrete. Here also the same thing, same formulas, but the only change is here we are looking at continuous random variables. Okay, there is no table now. So we will not be having any table, joint PMF table. So we will be having integrals. Everywhere it will be integrals.
Is there any way to ignore this double integral?
Ignore this double integral? No, there is no way.
I don't know. There is another alternative way.
Alternative way we are, see, it is being reasoned. Will there be any alternative way for other than area under the curve? Will there be any other alternative we have to think of? So we have to think of. Is there any ideas we can develop on that ideas? Okay, as of now, what we know is area under the curve. If you want to get an area under the curve, you have to integrate. Okay, so Riemann sum is one. Maybe if you are okay with errors, you can go with Riemann sums. Even that is also.
Riemann sum, what is this?
So Riemann sum is, so from Riemann sums only these integrals comes.
Math 2.
Math 2 or math 1.
We studied in math 1 also, sorry.
So
it was not in the maths too.
But if you
Riemann integral, Riemann sum was there. Yes.
Riemann sum was there in max 1.
Yes,
right?
yes.
So that is one. So apart from area under the curve, we have to think if we can define our probabilities in some other way, then we might get. So these all are under in the research. So if we have ideas, we can develop on this. Okay. As of now, the only way is to follow the double integral. So this double integral means area under that bigger curve. So the two-dimensional curve. So let us start one by one. Let us start with joint density. So in week 4, we have seen what is probability density function for one random variable. And it will be same that kind only, but here we have two variables. So joint density is also a function fxy, and this fxy is said to be a joint density function if it satisfies these two conditions. So the first condition is this function should always be greater than or equals to 0. Okay, just correlate with probability density function. So there also our fx of x or fx should be greater than 0 for all x. So in the same way here also our joint density, so density will never be less than or equals to 0, as this is representing the joint density function. So all the values should be greater than or equals to 0. And if I integrate throughout the supports of x and y, so from minus infinity to infinite and minus infinity to infinite, so this is y limits, so y integral or y limit, and this is x limits, so x integral. So you have to integrate
first
x.
We have to integrate treating y as a constant.
Y as a constant, and you have to integrate it within this, and then you have to integrate the other part, outer part, treating y as variable.
After putting the limits, right?
Sir, if we keep the inner as dy and outer as dx,
this limit should go. No. Okay, I will tell you.
Sir,
so
here x and y are dependent or independent?
X and y are independent.
Means anyone can be integrate in any order. We can integrate first x, then can.
See, this is that independence and dependence we have to check, right?
No, I'm just talking about the independence of the variables. Just they are x and y are dependent and independent variables.
That also depends on the curve we take.
The area, the x and y are dependent variables.
See, sometimes x may be dependent on y. Maybe.
Yes.
Right? Even in these cases also. So functions I can define it like. So I have few examples I can show you by scrolling down.
If the marginal densities product is equal to the point density, then it's independent.
See here. See here, in this example, y is in between 0 to 3 minus 3x by 4.
Yes, sir.
Okay. Here y is dependent on x. Okay. So depending upon the x value, my y limits will be varying. Okay. So there can be cases
like when x and y are dependent. So the example that you show, this is where the range of y is dependent on the value of x, right?
Range of y is dependent on value of x, and as well as the random variable.
But for them to be dependent, it is not necessary that it should be of this form, right? Where range is dependent.
What I was saying is in this double integral, suppose we keep dy in the middle and dx outside. Sir, will it change the value of the integral?
It will not change if you change this integral also.
Suppose outer integral is minus infinity to infinity and outer dy instead of dy we have dx. And inside we have dy and inner integral is again from minus infinity. Will it give the same result?
Same result. You can see this, right? I have written something here. So if y limits are from a to b and x limits are from c to d, so when you take that c to d limits integral inside, then you have to write dx inside. If you want to take dx outside, then you have to take this cd integral limit also to the outside.
Okay.
So the inside integral represents the first one.
Yes, that is right.
And the outer one.
So we can reverse it. You can
reverse it if you reverse this integrals.
According to our convenience, we can reverse.
According to your convenience. So that is what I have written. This is y integral, y's integral or y's limits, and these are x limits because dx was written here. So first we have to integrate along dx by treating y as constant, and we have to substitute the limit values of x, and then we will have function with only having variable y, or it may not have y also. Then you have to integrate with respect to y. So first integration will happen for the inside variable and then the outside variable.
Yes.
Okay. We will see how to solve this. But the condition for joint density is these two. So in order to be a function fxy, to be a joint density function, that function should always be greater than or equal to 0. And if I integrate along y and x, this function, then it should give me the sum, the integral value should be equal to 1. Okay. So if I have to explain it in 3D, so treat this as x, this as y, and this is fxy. So if you have something like this, some height, volume or area under this region is what this integrals will give us. So area under this region should be equal to 1. So it is slightly clumsy. So you treat it as 3. So I am showing 3D in 2D and you are seeing on 1D screen. It will be difficult.
It is volume only.
It's a volume.
And this integral is nothing but the probability, right?
So here it will be probability. So area under the curve will give us the probabilities. Okay. So this is joint density. So if I ask you questions like check whether this is a valid joint density or not, you have to check these two conditions. If these two conditions are satisfied, then it is a valid joint density function. And for every fxy, for every joint density, there exist two jointly distributed continuous random variables x and y. So I can define. If I have any fxy which satisfies these two conditions, then for that fxy, there exists two random variables x and y which are continuous, both are continuous. And if it is continuous, if I want any region event A or any region A, if I have to compute the probability that this x and y will take values inside that region, if I have to compute that probability, then I have to integrate along that area. So this is what the main important concept I am talking about. So finding this region's limits is the difficult part. So if I have to compute the probabilities that x and y will lie in that region is actually equal to double integral that region limits fxy of times dx dy. So finding these limits is the very difficult part, the most difficult part in week 6.
So sir, basically like when we had discrete random variables, we were trying to find the probability of x taking a value, y taking a value, and then we had joint distribution, x and y both taking a specific values. And in continuous, we do not have probability at taking a values. We have x lying in this range, y lying in this range, and now x lying in this range and y lying in this range, both together.
Correct. Right.
And that will define an area under the curve, right? On xy plane, that is an area.
Yes.
And we want to find volume corresponding to it. That is what you are saying.
Volume corresponding to it, yeah. So double integral will give you the volume actually. And that volume will be somewhat, whatever the volume you get, that will be the probability that both x and y will lie in that particular region. So these all things professor has discussed. When we take examples, you will get clear idea. And yeah, this fxy, other denotion is just subscript xy random variables. We just put xy. So it denotes the joint density of x and y. So even if I write like this or like this, it represents the joint density of x and y. And the last one is support. So the support of xy is basically all the points x comma y such that this particular joint density value is greater than 0, strictly greater than 0. So everything you can correlate. Whatever the support for single random variable, so that support holds for the double variable, two variables. So our joint density should be strictly greater than 0. All such points x comma y will come into our support. Okay. Now as these are points x comma y, our support will be in a region. So all, if I consider,
it will be an area, sir, right?
it will. This is how it will be. So if I treat x, y, so it will give me some regions. Maybe this region, circular or square, maybe triangles. So
Sir,
whatever
I
the
have
region, this fx,
some
y is
doubt.
greater than 0. That is called support. Yeah.
Sir, little doubt.
Hmm.
Whether it is a double integration related to the area or it is a volume. I think it is a volume. Then if it is a volume, then why it is the area? This is area and volume. I am getting confused.
Okay. So area is between x and y. Okay. So between x and y, we will get a graph. This is the joint. So we used to draw the joint table, right? If it is discrete, we used to draw a joint table. If it is discrete case. Here we will try to draw the regions in which our both random variables can take values. Okay.
X takes value something and y takes value. There is a two-dimension thing, and a two-dimension thing is the region. It cannot be a volume.
This is a region. Okay. And for this region, corresponding region, there is a third axis, which is the density function.
Here is the third axis, sir.
So the third axis comes in a different graph.
Okay.
Okay. Until now, we are seeing the top projection. So from here, if you see, if this is how it will be.
Okay, density function is also there.
Then density function, if takes some value,
it is a layer of the density function that become a volume.
And area under or volume under this will give us the probabilities.
Right.
Thank you. This is the top projection. From top, if you see, this is how it will be. This will be area.
Right.
So one observation.
So the
in all these graphs, it will lie on the first quadrant only.
X and Y in the
first quadrant only. Because in the lectures also, professor draws everything in the first quadrant, and you are also drawing in the first quadrant. So it will be lying in the first quadrant only. If fx y greater than 0 means it is in the first quadrant.
Yeah.
Why the first quadrant only?
It cannot be in 4 quadrants. No, sir. Above, like no, f of x comma y cannot be negative. So there are 4 quadrants for that. No, sir. To outfit.
Okay, x and y will always be positive, so it must be in the first quadrant.
It must be in the first quadrant.
No, x and y can take negative values.
Yes.
F of x comma y cannot take.
F of x comma y cannot take. See, in this in this three-dimensional curve, this should be above xy plane. This whatever the curves we get, that should be above xy plane. So here the regions can be like this also. So until now we haven't given, maybe we will try to give.
But area is a vector quantity. I think it can be positive or negative.
Yeah, it can be positive or negative. Area cannot be negative.
Why, sir?
Region can be negative or positive, negative side or positive side.
Okay.
Can fxy take negative values also? Can fxy take negative values?
No. Fxy. See, there will be 3 axes. Okay. So this is fxy. This cannot take negative values. That means whatever the curve or the 2D curve comes, that should be above x and y plane. So this is x and this is y. So let us take the first example only. Okay, so this is y, this is x, this is y, this is fxy. Okay, suppose I say x is a random variable that is uniform between 0 1. Okay, so x takes values between 0 to 1. Okay, and y is also a random variable which is also uniform 0 to 2.
So that can be
So that
negative
means
also.
y can take
Take negative values also, na sir?
that
-2 to 2. Suppose.
okay, minus 2 to 2. Let's take
Yes.
minus 2 to 2. So it's minus 2 and this is plus 2. Okay, so y can take these many possible values. Okay, now you see x can take from 0 to 1 and y can take from minus 2 to 2. If I look at the joint, so x is taking this joint x comma y points, so x can take 0.1 and y can take 2. So like that, x can take any value between 0 to 1, so 0 to 1, and y can take any value between this. If I look at the joint,
This is
so
spot of x, right?
Huh?
This is our spot of x comma y, right?
These are the possible points of x comma y.
But say it is
So
uniformly distributed, na sir? So it's definitely spot.
Definitely
Spot of x comma y, since they are uniformly distributed.
Support. So this is the region okay. So this region, if I look it in the 2D plane only x and y, it will be like this. So x is between 0 to 1 and y is between minus 2 to 2. So like this, minus 2, 2. So this is the support of x comma y. So whatever the point you pick, that is a possible value for, so whatever the point you pick, like 0.5 into 0.5 comma 1. So 0.5 comma 1 is basically x taking value 0.5 and y taking value 1. So that is a possible case. So like this, x can take any value between 0 to 1 and y can take any value between 2 to minus 2 to 2. So all these region points are possible values for x comma y. For this, so this is being uniform. I'll just discuss what is uniform distribution is, then you can be able to get fxy of x comma y, which is the joint density. So if I say, when will we say 2D uniform distribution means, if there are two random variables x and y in a region D. So consider a region D. Let's suppose say this is our region D. So in this region, I say this x comma y is uniformly distributed. So I say x comma y is uniformly distributed if they have the joint density as, so my fxy of x comma y is equal to 1 by area of region D when x comma y belongs to D and 0 otherwise. If the joint density is like this, then I can say x comma y are uniform, x comma y. So this is combined, joint. So now this is a new random variable. X comma y is a point. Okay, on xy plane it is a point now. It's not single variable now, it is two variables here. So x comma y is uniform in the region D if they have joint density as like this, 1 by area of region D. So if the area is D square units, then this will be 1 by D. So if this joint density value takes 1 by d in the region D and 0 otherwise, then I can say x and y are uniform in the region D. So now in this case, you see x can take any value between -0 to 1 and y can take any value between -2 to 2. And let's suppose say if it is uniform, if it is uniformly distributed in this region. So what I have to do, I have to compute the area of this region. If I
1
say
by
this is
4.
the region D, so what is the area of the region?
4.
Area of this region?
4.
So this is 4 and this is 1. So area is 4. So fxy of x comma y takes value 1 by 4 when x comma y is in the region D and 0 otherwise. So now you see this particular fxy of x comma y, let's suppose say this is the z, third axis z. So this value z takes 1 by 4 in the region, in this rectangular region, and 0 otherwise. So if I have to plot that in this dimension, if I say this is 1 by 4,
sir, what is the logic behind 1 upon the area? Why so?
Integration should be 1, so volume should be 1, right? And
Hmm?
so if you take any value k and multiply it with the area, then it should come out to be 1. So that should be 1 by area.
so
Right, sir?
No, sir, I didn't get it.
okay, if it is uniform, the probability that at every point, probability density should be same for a, should be same, right? Uniform case. Agree?
Yeah.
No. In one variable case, if x I say if uniform 0 to 1, any value, so what will be our fx of x? It will be 1 by
1
length
by
of
2.
this. Length of this 1, right? No, this is continuous. Yes. This is continuous, square bracket, not the third brackets. Continuous case.
Sir, make it 1 to 2 or 1 to 3.
So uniform 1 to 2. Okay,
1 to 3 maybe.
It's the interval. So it's the interval now. So this will be 1 by.
Not discrete.
When I say uniform, uniform means x taking value 1 to 3.
Same.
So the density for 1 to 3 should be same. Okay, it is independent of x. Okay, so that means it should be a constant k. So from there you can say if it is constant k, if I integrate it from 1 to 3 dx, I should get 1. So for this will be kx, limits are 3, 1, 1. From here 3k minus k is 1, 2k is 1. From here k should be half in order to be uniform. So this half means 1 by this 2 represents the length of this interval. Similarly here also, when I say it is uniform, my density value is constant for any xy. So take it as a constant k and integrate it along the support, along the region D. If you integrate, let's take k dx dy. So if you integrate, you should get 1. Okay, so k you can take common. So region dx dy. So this region D is nothing but the support. Okay, so and if I integrate it, double integrate, under you will get the volume under this D, region D. Okay, so that volume will be, so if I have limits I can compute. I just said d square units. If it is volume, will we get?
So we can also say now like it is equivalent to volume, right? So
Mhm.
volume is whatever is the area of the base into the height that it is taking, right?
Hmm.
And the area is basically from what we calculated D, right? So D into K should be equal to 1.
So this is actually area, right? You are going to get the area. We are going to
This
get
is
this area.
volume, sir.
Yes, sir. We'll get only area, sir.
So integrating along x and then integrating along y.
Y. Yes, sir.
So we will get this area. Why am I saying volume?
Volume is we'll have
Like
3
that
integrals.
integrating over dx dy, na? So you'll get volume, na, sir?
No.
So you can integrate from 0 to 1 and outer integration from -2 to 2. And then you will get K as 1 by 4.
Sir, it is the surface integral, so double integral.
Okay. Let me take it like this then. So if I have given area as d square units, I will take it as x is taking from 0 to 1 and y is taking from 0 to d. Okay, then we are going to get area will be d. Here limits will be k integral from 0 to d, 0 to 1 dx dy. So if you integrate it,
You should get 1.
you should get 1.
There are two constants, d and k. If you take, there are two.
So from here 0 to d, if I integrate this, it will be x. So x limits from 1 to 0 dy and it will be 1. And again, if you integrate 0 d, you are going to get y and limits are d and 0. So from there you will get d.
dk equal to 1.
So k into d will be equal to 1. From there we are going to get k will be equals to 1 by d. So that constant should be 1 by area of the region.
We have taken one side as 1, sir. That's why it is like that.
No, not like that. You can give me, I just said the area is d square units, okay? If you take any other limits also, it will work, but the area should be d. How will that be d? You can take 2d and d by 2 also. Sorry, square root.
Area is d and the height over this area is 1 by k.
Correct. What should be the height? So this is actually k times area of the region.
Yes.
So this k is basically the height which you are seeing here.
On the z axis.
On the z axis. So this height here, whatever height you are seeing, this is k.
In this case, it is 1 by 4.
In this case, it is 1 by 4.
Sir, one doubt, sir. So if like we had here, x is uniformly distributed from 0 to 1, right? And y is uniformly distributed from -2 to 2. Given both of these conditions, does it necessarily implies that f of x comma y is also uniformly distributed?
F of x comma y is also uniformly distributed. That you can check using the independence condition.
Yes.
So this
it's not necessary, but right?
It's
not necessary that if x and y are uniformly distributed in their own regions, it's not necessary that they will be uniformly distributed jointly, right?
It is not necessary, correct. It may not be necessary. But if they are independent, then the joint will follow uniform.
Yeah, because then it will just be multiplication of margin. Yes. Good.
But see, this is somewhat trickier. You have to, every time you have to think about a third axis, which is fxy in this week 6. So not only working on two-dimensional. So like these examples we have. So first understand this is how it will be. If it is uniform distribution, then the joint density will be 1 by area of the region. What you have to do is you have to compute the area of that particular region, support region. Then the joint density will be 1 by area of the region. But every time you have to be very careful that in the activity questions or whether it is practice or anywhere. So if you have given like this, then always remember there will always be a third axis which represents fxy. Okay. So if it is uniform, you will have a slant, straight planes. If it is not uniform, then you may have curves also.
It may not always be uniform. No, sir.
It may not always be uniform. So that is why you might get sometimes wavy curves. Okay, but you should always keep in your mind that there is a third axis which is not being visible. And whatever we are seeing is the top view. So how this x and y are jointly connected. So jointly distributed. So this is an example, very simple example. Suppose x and y are uniform in this region D. What I want is I want the joint density function. So what will be the joint density function?
So 1 by 12 if it lies in this region.
So 1 by area of D when it lies in this region and 0 otherwise. So for this we have to compute area of D. So as this is a rectangle, you can compute the area. It is 4 times 3. So this is 3 and this is 4. So 4 times 3 will be 12. So from here it will be 1 by 12 when xy is in region D and 0 otherwise. So this works only for uniform cases. Okay. So if we mention it is uniform, then you can do this. Directly compute the joint density.
Could you just scroll up slightly? Over here, just this line where we're double integrating from 0 to 1, if I'm reading it correctly, and then from 0 to D. Why did you take 0 to 1 for dx?
Just like that. I just mentioned only area is D square units.
Okay. You just took 0, 1 just for the sake of it.
You can take 2 root. If you wanted to check, you just take 2 root D and root D by 2. Then also you will get D. So this double integral actually gives
you just needed something that would give you D.
Even that will also give us D. So this will actually give us area of region D.
Okay. The 0 and the 1 should be such that you must get D, right?
Product should get D, right? So I just took a rectangular region. Okay. So if I say that the area is D square units, then my length and breadth should be, if I do the product, I should get D. So that is how I took.
Got it.
So it was just one example. You can take, so just now I said, right, you can take 2 root D and root D by 2.
Yeah, so that will give you D. Okay.
Even that will give you product of these two. So 2 root D into root D by 2 you will get if you integrate.
Right, thank you.
Then also you will get D.
Yeah. The integral will give us the volume, no, sir? Integral will give us the volume, no? Just like in one continuous variable, the PMF, if we integrate, we got the area under the curve. So similarly here, we are integrating over the area, so we'll get volume, no, sir?
Okay, so in general we get volume, sir, but like even in one variable, if you are integrating f of x dx, we get volume. But if f of x is constant and it comes out and you are just integrating dx, then you get a point, not length, right? So in the same way, right, here the constant comes out, so now you're integrating, you are getting an area. If you integrate just only dx, you get a point, not length.
Constant is just a scalar. We are
If we integrate dx over a length, means suppose I integrate dx from 0 to 1, will not get point. It will give a length.
Yeah, it will give length, and
No
then
area.
we will get breadth, and length into breadth we are going to get area.
Area, and this is dx dy. It is a surface area, and it is a surface integral. Actually, this integration is this area and volume, a lot of hodgepodge. This creates a lot of confusion.
So simply when f of x is constant, and if you're integrating f of x dx and f of x is constant, then f of x has come out, and when you are integrating only dx, what you're getting is a length, not an area. So it goes from 2-dimensional to 1-dimensional. Now in general here it is 3D, but when it comes out as a constant, then you are getting an area, not volume, in the same sense.
Yeah, correct. So if I have fx, let's suppose say fx is, if it is like this, if I am integrating it from 1 to let's say 4, so 1 to 4 fx dx will give me area under this curve. Okay, so if there is a function inside and if I am integrating the function, I will get area. But if my fx is some constant value, so even now if it is fx and but this is constant c, if it is independent of what we say x, if I bring it out, so here you see if it is c, even here also it is area under the curve.
Fx may be anything, sir. Fx could be constant or it could be an expression also. What we are doing is when we are integrating fx with dx, we are getting
no, sir. That's not what I am saying. I am saying suppose please write sir. Integration of f of x dx. Now if f of x is constant, it comes out of integral, right? So it is f of x into integration of dx. So now integration of dx is not area, because f of x into integration of dx represents area, right?
Area. Right. Correct.
That's what I'm saying.
Okay. So leave it until now. Just forget everything. I will just explain you. So integral inside k times dx dy is volume. Okay.
Please repeat that.
So this integral fxy dx dy, so this will be the volume under the curve fxy. Okay, and this fxy in volume we have three things, right? If I treat it as cube or cuboid, we will have height, length and breadth. So that height is basically this fxy. If this is constant, if that constant is height, if that height is constant, if I pull it out of my integral, so my height is pulled out. So when I pull out my height, I will be having length into breadth, which is area.
But integration of constant is x, no, sir. Integration of constant is, if you integrate a constant, that constant into x is the integration of that, no, sir.
But we are not integrating; we are just taking it out, right?
No, sir. If you take fxy out, it means fxy is a constant.
Is a constant, and it is actually being the product here.
Yes, it is being.
So it is not going out. So basically, we are not taking it out. We are just integrating it. Okay.
If you are integrating, this is a two-dimension matter. I think fx by dx and dy, it cannot become an area. I am confused here. How it become an area? It will be a volume. It remains the area only.
Okay, let us discuss this thing clearly.
Sir, please clear this from. Give me some example.
Can I explain a bit?
No, sir, you are
Just
not
one
able
point,
to
sir.
explain. I'm not getting. You are explaining very good, but I'm not getting your point.
Just
Let
one
instructor
point I want to
explain.
add.
The instructor is a. Please allow him to speak.
Okay, so this is volume under the curve fxy. Agree with this?
Yes, sir.
Okay, I'm okay. Please go ahead. If he is a balloon, let us.
This is volume. Will you agree with this? So my fxy is constant within some region d, and it is 0 otherwise. So I am taking double integral of fxy, which is k dx dy.
Sir, okay.
So,
please give me one real example so that
real
it will
example.
give me example.
Okay. Okay, let me take.
Then they integrate it, sir. It will be ky something.
So this is, let's say this is k. So we will try to find what is k.
Sir,
Okay.
yes.
So the limits are 0 to 2, 0 to 2, k dx dy. Correct?
Dx dy, right? Yes, sir.
Is equal to 1. Is equal to 1.
This should be equal to 1.
Yes,
and here we are looking at combinedly, this is volume, this is volume.
Yes, sir.
This whole is volume.
Yes, sir.
Now even if I bring k out, that k times this will be volume.
Yes.
K times area. Okay.
K times this double integral dx dy. 0 to
K
2
times the area. Yes, yes, yes.
So
Okay.
this times this only is the volume, right?
Okay.
So k is a scalar, sir. It is just multiplying the volume. This integration is also still a volume.
Okay.
Because
yes, if it is a scalar, then it only multiply the area.
Sir, it is height,
Then
sir.
how can
K is height.
K is height, I understand. See, I'm not saying, see, this whole thing is volume. Agree?
Sir, can we relate this with the units? Area is a square meter, and if it is a height, then this should be meter cube. Relate in this way, then it will be more clear.
Okay. So k times this is some meter cube. It will be meter cube. Okay, no need to bring k out.
Suppose instead of k we have an expression. Suppose instead of k we have an expression x square plus y. Suppose.
Then you cannot bring it out, right?
Yes, we cannot bring it out. Then it will be a volume only.
It will be volume only.
Yes.
See, bringing k out, if it is that confusing lot, keep k inside only. No need to bring k out. So keep k inside only. Compute the integrals. So what this will be? So if I am integrating 0 to 2k, it will be
kx 0 to 2. 0 to 2.
0 to 2 dy. And this will be 0 to 2. If I substitute the limits, I will get 2k dy. Then if I integrate it, I'm going to get 2k y.
Yes,
limits
sir.
are from 0 to, now we are going to get 4k final value. Correct?
4k. That should be equal to 1.
So 4k is the volume.
Yes.
Okay, 4k is the volume. Agreed?
No.
Yeah.
Sir,
4k meter cube.
K is the if k is the constant, then it cannot be meter cube. It will be meter square only.
Why it will be meter square?
If you are taking k as a constant, sir, how it become a meter? It remains the constant.
K is constant means k meters.
K meters.
See, fxy will always be k meters.
Okay.
K is not unitless. K is a unit.
K
quantity.
units. K also has some units. Okay.
Like units of dx and dy in the same units. If it is a unit.
Okay, I will give you one more example then. Simple. So let me take this cuboid. Okay.
Sir, go ahead, explain this.
This plane. Sorry, this plane. This plane is z is equals to 2. Okay. I want double integral 0 to 2 z dx dy. Will this z will have units or not? Even though it is constant, will it have unit or not?
Yes. It is a volume.
It is a volume.
Yes.
So I just replace z with k.
Yes.
This is a volume.
Yeah.
This will be volume.
Yes.
Yes, right. Z or k or any variable, it is same. So this whole thing is volume. Even though I keep k inside or outside, that whole thing will be volume. Okay. So even I can write k times double integral 0 to 2 dx dy. Now the volume will be k times this double integral will be the volume. We cannot ignore this k. Okay, and because it is constant and independent of x and y, we can take out, that's it. The product of k as well as this double integral is volume. And this k plays height role, basically. If this plays height role, then this double integral will give us the area of that region. Area.
So suppose k is 1 then, sir?
Even though k is 1, what happens, man? It will be area. This is see, area means actually it is not area. But the when you compute this double integral, it will equal to the area, that's it. Okay, we can have some conclusions, right? Sometimes if you derive something, that will be equal to something else. And we will define it as a theorem and saying that if you compute this.
If we bring k out, then 1 remains here, na, sir, inside the integral.
Inside 1 remains here.
1 remains, yes. That is what we integrate, na?
That is what you are going to integrate.
0 to 2 dx. 1 is what we integrate, sir. So, and k is just scaling that volume. K is just scaling that volume to k units. Otherwise, we are integrating 1 to 1 volume. And then after that, we are scaling it to k by multiplying it with k.
This will comes out to be the area. This double integral is not area. This will comes out to be the area of that region. Okay. Even if you compute this double integral, or if you compute this area of this region D, both will be equal in all possible cases. Okay, so we are not saying this double integral will be area. If you compute this double integral, it will give you the area of the region D. So once you compute the value, that value is nothing but the area of the region D, area of our region. Confused? Got something? Or do we have to think more about this?
थोड़ा आ रहा है, समझ रहा हूँ.
What will be the units of this, sir? What will be the units of this?
Units of which?
This leave k outside. What will be the unit of this?
Even though if you leave k outside, it's just the scalar multiple. This units will be meter cube only.
Meter cube. That's what I was saying. That
meter cube only.
Although it gives the value of the area, but units will be meter cube.
Units will be meter cube, but it will, the value, whatever the value you are going to get,
that
will be equal to the area of the region. Don't need to compute this.
The whole value, counting k as well is volume, right?
If you multiply k, you will get the exact volume.
Sir, we can also think it like when we say that integration of f of x dx is area, like for single variable.
Yeah, this is
when
area.
we say that now how, yeah, so when we say that let's take a point where and dx is a very small region and we multiply it with f of x, right? And if you take f of x out of integral, you are just adding dx, a very length on x.
Okay, if we
right?
wanted
So
to go in deep of calculus, so how many of you know what is this dx and dy? So after integral, why are we writing this dx and dy?
These are like
There's small
There's a small length.
small length in
on small length on x and small length on y.
Small. So it's actually summing the rectangles. So how we are computing areas is, if this is the curve, if I wanted to compute the area under this curve, we will take small dx and we will multiply it with the height. So this height will be at that particular point. And similarly, the other rectangle, other rectangle, other rectangle. Continuous summation is nothing but the integral. So that is how this dx and this f of x. So this f of xy is the height. Now in 3-dimensional, this is the height and this dx is the length and this dy is the breadth.
Yes.
Okay. These product of these threes and we are summing along x and y's will give us volume basically. Okay. So this total will be volume. Even though if f of xy is inside or outside, anywhere, total will be the volume. Combined of f of xy, dx and dy is volume. Okay, ultimately, if you compute the double integral, you are going to get volume.
But sir, if f of xy is outside, then we are just adding dx and dy inside the integrals. So those integrals will be adding the area. So will we get an area?
That will be equal to area. That's it. Okay. So if this is constant, if I bring outside also, there will be 1 into, so there will be something called 1 into dx dy. Okay.
Yes.
So this one plays the height role now. So we are normalizing things. So let's remove that constant. Let's compute what is the volume if the height is 1, and that will be the area basically. And multiplied with that constant will give you the volume.
Volume.
Complete volume.
Okay. Yes.
Okay. Yeah. So this is about see this things you can actually infer. So if I am simply integrating dx dy along the support or along the region, this will always give you area of that region D. Okay, so think it in calculus way, not in this joint or anywhere. So if you are interested in calculus, so if I take dx dy and if I double integrate inside some region, it will give me the area of that region D. So the volume is taken to be 1, the height to be treated as 1. So there is no height role played. So that will give us area of the region D.
सर मुझे लग रहा है ये जो हाइट आप एक ले रहे हैं ये कंफ्यूजन कर रहा है. हमें हाइट का जरूरत नहीं है. हम तो यहाँ पे प्रोबेबिलिटी डेंसिटी फंक्शन के साथ में इसको इंटीग्रेट कर रहे हैं. प्रोबेबिलिटी डेंसिटी फंक्शन आपका fxy है. जब प्रोबेबिलिटी डेंसिटी फंक्शन fxy है या समथिंग इट इज ए कांस्टेंट या कोई डिपेंडेंट है इंडिपेंडेंट है dx by dy, वो वॉल्यूम हो रहा, वो तो हमने वॉल्यूम के साथ में उसको एक तरीके से मुझे वो कर रहा है कि हाँ ये वॉल्यूम को रिफ्लेक्ट कर रहा है. 3 डायमेंशन हो जाए, 1 डायमेंशन इज द प्रोबेबिलिटी डेंसिटी फंक्शन एंड two dimensions are dx and dy means the area, so that will be a volume. So मुझे लग रहा है इस टाइप का कुछ बनता है. Actually, I'm not very much expert. I am a man of humanities, but I understand little bit of this mathematics philosophical way. That's all.
Okay.
So I think we should move on with this.
Yes, sir. Please.
Yeah. So let's move on and let's solve problems. Okay, basically.
Yes, sir. That will
I'll
be
take
better.
some 15 minutes more. We will continue in the next class. Maybe we can have that solve with us can be. We will directly upload the previous year session, and we will in that solve with us session we will again discuss this concepts if required. So I'll just go through quickly. This is again one more region you can see, and I said it is uniformly distributed in that region D. So here also we have to find fxy of x comma y. So how do we do this?
Find the areas.
Half into base into height. It is triangle. So half into base into height will give us 6. So the area of the region D will be 6. So fxy of x comma y will be 1 by 6 when x comma y is in this region, and it is 0 otherwise. Now, if this is like this, fxy of x comma y is 1 by 6 and all these things we can compute. What if we have asked you like this? What is the probability that x is being greater than y? So inside this region, we asked you to find the probability that x is greater than y. So what will we do?
Give a minute, sir, please.
We'll draw x equal to y line. And
Correct.
then
So that should be your very first step. So the step one is whatever the inequality is given, greater or less than or equals to or greater than or equals to. So you remove that inequality and keep equality sign.
X minus y.
So I just remove greater than symbol and keep x is equals to y or y is equals to x. So once you keep this, then draw this line. Okay. So draw the line y is equals to x. Here, if I draw that line, how it will be?
Passing through
So y
0,
is
the 45 degree.
passing through 0, 0, and it is going from 1 comma 1 and
45 degree. Okay,
2 comma 2 like this. So once you draw this, this is y is equals to x or x is equals to y. Correct? Now this line divides xy plane into two halves, two regions, above this line and below this line. Okay. So this is one region, this all is one region, and this is another region below that line, above that line. So this works for all lines, not only x is equal to y line. So one region will represent y greater than x region, and another region will represent y less than x or x greater than y region. So what am I saying is, if you have
check that by putting the values, sir, or
you can check that by putting one point. One point is enough. If there is any straight line cutting xy plane into two halves, it will divide xy plane into two halves. So this line y L, this is one region, above line and below line is another region. So if this line is something y is equals to x plus 1, then this region represents y is greater than x plus 1 and this region represents y is less than x plus 1. Okay. On this line it is equal. Above this line y will be greater than x plus 1 and below this region y will be less than x plus 1.
Yes.
So every line divides xy plane into two halves, and two halves have opposite inequality signs. So you can take few examples and check. This will work for every line. So here our case is x is equals to y. Draw that line. First of all, draw that line and identify the region which represents this x greater than y. So you can just randomly take this point 3 comma 0. Here x is 3 and y is 0. So you see x is greater than y. So in the same way, if you pick any point below this x is equals to y line, your x value will always be greater than y for every point. And on the top, it will be y greater than x. So for example, 0, 2. So x is 0 and y is 2. So 2 is greater than 0. So it will work for any point. So all the points will satisfy this condition y greater than x. And in this region, all the points will satisfy this condition x greater than y. So, but our question is, we have to find the probability that x is greater than y. Okay. So after drawing this line, x is greater than y is this region. This region. So we are not worried about these regions because here fxy is 0. So there is no density. Okay. So we have to worry only within our region D. So within our region D, this is the region where x is greater than y. So I have to find out this probability. So if it is uniform, you should always remember, if it is uniform, so if I ask you probability that x comma y is in one region D1 or some region C, then that will be area of C divided by area of total area divided by area of that region C. So here we asked you the probability that x is being greater than y. So for that you have to first identify the region. So first step is remove the inequality and keep the equality sign, and after that you will get a line. So draw that line, and after drawing that line, identify the region that represents this x greater than y. So that region will be this green region. Now finally what we have to do is, you have to find the area of this region and the probability that x will be greater than y will be. So I have to find
3
this area.
This will be 3.
Half into 4 into.
What is the area of this region?
3.
So 1 by 7, sir.
Huh?
No, wait a second.
No. Yes. It will be 6.
24 by 7 it is coming, sir.
So you can see the height is 2 and the base is 4. The area will be half.
So why is height 2, sir?
Not 2, sir.
It's not 2, sir. The triangle is not symmetric, sir.
The line is not.
Okay. Yeah. Sorry.
We have to find the equation of the line joining.
Line equation will be x by 4 plus y by 3 equals to 1.
Correct. So x by 4 plus y by 3 is equals to 1.
Oh,
so
yes.
Simplify it. 3x plus 4y is equals to 12. This is what the line equation will be. So after that,
intersect it with y equal to x.
So y is equals to x, it will be like 12 by 7 comma 12 by 7. So this point will be 12 by 7 comma 12 by 7.
Yes, sir.
So from here height is 12 by 7 and the
height
length
is
4.
Base is 4.
Height 12 by 5, sir. It is a perpendicular.
12 by 7, right?
How, sir? This from origin we draw a perpendicular. Okay.
If I draw a perpendicular, the y coordinate will be the height. And the y coordinate is 12 by 7.
Right.
So 12 by 7, area of this region will be half into 12 by 7 into
4.
So this will be
24 by 7.
24 by 7 is this region's area. So in order to get the probability, so you have to divide it by 24 by 7 divided by area of D, the total region. So the area of D is 12.
12. Huh? What? No, 6.
Oh, sorry, 6.
Yes, area the 6.
6, sir.
So divided by 6. So we are going to get 24 by 42, which will be 4 by
7.
So this is how you can compute. So there are 2 to 3 steps involved in these kind of problems. So when it is uniform only. Okay, there is no play of integrals, no need of integrals to compute the probabilities. Just with areas itself, we can compute the probabilities of what they are asking or the event. So here
Sir,
the event is
like what I got the same answer, but I approached it differently actually. So
using integrals, is it?
Yeah, so what I did is I calculated the area of this the triangle, below triangle, and multiplied it with our jointly distribution function
Jointly distribution
to find the volume.
See,
Because that volume will represent those values, right?
Correct. So multiplying it with joint density is in uniform case, dividing it by area. So both are same, right? Yeah, it's the same thing. So this 1 by area of D is nothing but fxy of xy. So whatever you did is also the same thing into 1 by area of D. So this 1 by area of D is nothing but fxy of x comma y.
So we are not able to do it because it is a uniform, right? Otherwise, we would have to integrate.
Integrate it. So this works for only uniform case, okay? So now
how to find the area of D?
How to find the area of D? So for this, you have to find area of D. D is total area. This area.
Whole area.
Whole area. Whole area. It's right angle triangle, right?
Okay.
Right angle triangle and height is 3 and base length is 4. Half into 3 into 4.
Half into 3 into.
From there you will get 6. Okay. Yeah. Now do this. I just made this question just because of this thing. So how many of you understand this thing? So what is this represent?
Cartesian product.
Cartesian product of
0 to 1
and 0.
R2, sir.
This represents an area, basically, sir.
Represents an area, region. Okay. So my question is, draw the region that represents this interval, this region. I want the region first, and then find fxy of x comma y. And I said it is uniform.
Okay. Sorry. I didn't write down.
1 by 3, sir.
Correct. So I'm apologizing for being late. So I will take some 15 minutes more. Is that okay?
Yes, sir.
Yes, okay?
Yes, sir. Please.
Now I will write.
It's a beautiful diagram, sir.
Which one? 0, 1, 2, 3, and let's say 1 and 2. Okay. Just forget about the scaling. Let's take it like this. Now the first region 0, 1 cross 0, 1 represents this region. So x is between 0, 1 and y is also, so this is x interval. So this represents x interval and this represents y interval. And this is the Cartesian product between x and y. And this gives us the area. So area between 0 and 1 and 0 and 1. So this will be the region. This region is only this interval. Okay, this region. And this region represents 1 to 2, x is 1 to 2 and y is 1 to 2. So when x takes 1 to 2, y also takes 1 to 2. So that is this region. Okay, it is a square between the intervals. So this 1 to 2, so if you are confused, this is nothing but 1 less than x less than 2 and also 1 less than y less than 2. So you have to identify this region. In which region my x also lies in between 1 and 2? So closed. So equal to. At the same time, y also lies in between 1 and 2. So this is the region. So whatever the point you pick, your x value and y value will lie between 1 and 2. And the third region is 2, 3 cross 0, 1. So now my x values are between 2 to 3 and my y values are in between 0, 1. So it will also form a square, and that square is this. Okay. And this is the region. So in this region, my x is between 2 to 3 and my y is between 0 to 1. So this is the region I am going to get, and I said it is uniform. So what I have to do? So combined of these 3 squares is my region D. So if I have to find fxy of x comma y, 1 by area of D.
1 by 3.
Yeah. So each of these squares have area 1. 1 plus 1 plus 1, it will be 1 by 3. And 0 otherwise. Okay. And okay. So if I want to find the same thing, probability that x greater than y. So how will I do? So just try to find
y equal
what
to
is
x
the
again,
probability. What is the probability that x is greater than y?
X equal to y, right?
Two by 3.
2 by?
2 by 3.
4 by 3.
Yes, sir. 4 by 6, sir. 2 by 3.
Someone said 4 by 3. And 4 by 3 is 1 point something. Probability.
No, sir. 2 by
2 by 4.
2 by 4. So if I draw y is equals to x line. See, first thing is we have to draw y is equals to x line. And then identify the region which is x greater than y. So below that line will be x greater than y, and in our support it is sufficient. So this will come under x greater than y region. This will also come under that, and this will also come under. So now I have to find areas of.
Sir, I have little small doubt, sir. Probability at y equal to x is 0, right, sir? 0 at that line.
At x is equals to 0 is 0.
X equal to y, sir.
X is equals to y is 0.
Yes, sir. At point and at on the line is 0, right, sir?
On the line.
Because x greater than y is region. Y equal to x is not a region, so probability will be 0.
Okay.
Thank you.
Yeah. So this is the region. So if I find the area, this area is 1, half, half. I am going to get 2. 2 divided by total area is 3. Therefore 2 by 3 will be the answer. Okay, this is how you have to do when it is uniform only. If it is uniform, then only.
Yeah, I was talking about this only. We are basically saying that every point has same probability within those areas, and that's why we take
same probability, same density.
Yes, same density. So yeah, so that's why we are able to divide it proportionally. So this thing, probability of x equal to y is 0. Can you please elaborate on that a bit?
See, probability of x being equal to y, if I try to find the region of x is equals to y.
So mathematically, I understand, sir. Like, but my mind is not able to get a hold on it. Like so x is equal to y is an event, basically, right? And y its probability is 0.
See, it's an event, and that event is basically. What I have to do, I have to add up all this values, right? on this particular line, I want the probability. Only these are the possible values. So when x is equals to y, there are something like whatever the points on this particular line, those are the possible values. Correct?
Yes, sir.
So from there,
if you think in terms of double integral, sir.
Double integral fxy dy.
dx, yeah.
And this is 1/6.
So it can come out.
And what are the limits of y? It is basically from x to x. It should only take x value, x, right?
Yes, from x to x, yeah.
From x to x, and
yes, y's limit, na, sir.
Y's
you put it in the
are...
x. You put it in the x limit.
Okay. Okay, you can treat it like what are the limits of x? It's from y to y only, right?
Y to y. Yeah. Same thing. Yeah.
Correct. So this integral will be 0. So y to y.
The inner one.
Inner one will be 0, right? So this is x by 6.
Yes. Got it.
That will be 0 and the whole integral will be 0. Double integral will also be 0. So the probability will come out to be 0.
So that implies that x cannot be equal to y.
That doesn't imply that. It can be equal, but the probability is negligible.
Okay.
So
like it was like the same thing that we did from when we moved from discrete to continuous,
right? Yeah, when we discussed from discrete to continuous, y at particular point, same thing. Okay.
Here for line it is 0, for there it was with point.
So that is for only uniform. Please keep this in mind, okay? If it is non-uniform, the problems will be like this. So the joint density will have some variables x and y attached to it. If it is like this, area divided by area will give you wrong answers.
This will be double integration, sir.
Now this double integral and finding the limits will come into crucial.
0 to 1 and 0 to 1, dx dy, dx and dx, dy.
Yeah. So now firstly check this. So within the given support, is 4xy dx dy is giving me 1 or not? So what is the integral?
2x square.
This will be 0,
4x square by 2y.
4x square y by 2. And it is from 1 to 0
dy.
So this will be 0, 1. If I substitute the limits, I will get 4y by 2, which is 2y. 2y dy. And if I integrate this, I am going to get y square.
Yes, it is
1, 0. We are going to get 1. Okay. So this is how it is. And this is a joint density for non-uniform case. Okay. So if this is non-uniform, then also the questions may be asked within a given some regions. Okay. So first draw that region. It's good to draw the region. So the region is 0, 1 and 1. So this is a square. But one thing you have to keep in mind, as I already said this, there is a third axis which represents fxy of x comma y, and that axis now it is 4xy. It will not be a plane, it will be some curve. Okay.
Yes, sir.
When x and y takes higher values, this 4xy product will be higher. When xy is very much nearer to 0, this product value will be very much nearer to 0. So if you can able to understand, I will draw it in 3D plane. Even though if you don't understand, do not worry. We will try to have one more session where we will use GeoGebra. GeoGebra is a good applet for 3-dimensional figures. So we can look at the 3-dimensional figures. To see, this is 1, this is 1, this is 0. Let's say if this is fxy, so at 0 it will be 0 only, the density will be very less. As it comes to 1, the density will increase. Slowly it will increase. Okay, it will be like, so the at 1, sorry,
At 0, 1 also it will be 0, sir. At 0, 1 and 1, 0 also it will be 0. At 0, 1 and 1, 0 also it will be 0.
It will be like an couch. So like this. So at 1, so I see I can't draw it in 2D plane, but it will be like, here it will be 0. Look at like a tent. Okay? So 0, and the values will increase as x and y values increase. Within at 0.5 and 0.5 it is 0.25. At 1 it is very much higher, like this. Okay. So like this, it will be like, so this is slightly slanted, some angle it will be. Okay. So we will discuss this when we use GeoGebra. That will be better. It is very difficult to show in 2D plane. But understand that when xy values are very much nearer to 0, my density is very much nearer to 0. When xy values are higher and higher, very much nearer to 1 and 1, my density is 4. So when 1 comma 1, when x takes 1 and 1, let's take, if it takes 1 and 1, then the density is 4. Okay, so the height will be 4. That is how you have to think about. And if I wanted to compute these things, so I will end with this today, and we will do other things. So
In the
maybe
previous
marginal.
example, this is just an example of a non-uniform distribution, or are we supposed to find something?
This is just an example of non-uniform problems, and now we will find these things. So what if we ask you to find the probability that x less than half,
0
and
to half
y
and
less
0
than
to half.
Now I have to integrate along the event, along the region. So x is less than half. So now see, this is the region, x and y ka region is this. So what we want is x should be less than half, as well as y also should be less than half. So that is this square, half and half. So within this square, it will be less than half and y less than half. So what you have to do is, it shouldn't be like area, total area. See, this area divided by total area, because the densities will change according to values of x and y now. So the density is not constant, not uniform. Now what you have to do is consider this region, and depending upon this region, you apply the limits. So look at the region. So what you have to do is, you fix one variable. So you fix x or y. So I am fixing x, okay. So what am I doing is, okay, I am fixing y. So I fix for some y. I will look at the limits of x. Okay, now I will write it here. So for some y, okay, half, right? This is half and this is half. So this is how you should take the limits. For some y, so this is a straight line. For some y, this will be a straight line. On that straight line, you just identify the limits of x. Now we are fixing y and writing the limits of x in terms of y. Okay. So now what will be the limits of x when y takes y?
y.
0 to 1 by 2, sir.
0 to 1 by 2. So what are the limits of x? So I have fixed y now. So I just fixed y. And for that y, I am just looking at the limits of x. So from where to where x can take. So in this
0 to half.
0 to half. This is half, right? Not 0 to y. This line is x is equals to half. X can take any value between 0 to half in this region. In this region also x can take any value in between 0 to half. So x limits will be 0 to half, and this y can run from 0 to half. So this y can be here, 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 here. Okay. So this is how you are going to get the limits. So this y can go from 0 to half. So firstly, what you have to do is you fix one constant. So one variable, you keep it as a constant. Treat it as at some place y. So for that place, you just look at the limits of x. So the limits of x are from 0 to half for that y. And that y can go from 0 to half. Okay, this is x limits. And these are y limits. So here x limits are independent of y because it is a square. So whatever the y is between 0 to half, my x can take 0 to half irrespective of y. So whatever the y takes from 0 to half, my x can also take between 0 to half. There is no restriction. So that is why my integrals will be from 0 to half and 0 to half. And
basically, to find the inner integral, we have to keep the y constant. So we treat y as a constant and try to find the limits of x for that.
X.
And once we do that, y can be generalized for whole of the region, right? Okay.
So this is like two things. You just move along this and after top to bottom. Okay. First find the x limits, horizontal limits, and then vertical limits. You can do vice versa also. It's not an issue. You can do vice versa. If you do vice versa, then it will be dy dx. Outer one will be the x limits and inner one will be the y limits.
Yeah, then the inner integral, we have to keep the inner integral constant basically, the variable of inner integral.
Variable of outer integral constant.
Oh, sorry, a variable of outer integral to find the inner integral, right?
So now you can compute this thing 0 to half, 4xy dx dy. So you just substitute the limits and get the value. Now what about this? I will end with this. So try to do this. No.
X plus y equal to 1 plus.
X plus y less than 1 we have asked. So remember the steps which we discussed here. So if it is x greater than y or anything, any inequality, so you have to follow that approach. And if this is non-uniform case, instead of area by area, you have to find the limits. Just I will give you 2 minutes, then I will discuss. So firstly, I need what are the limits of x and y. So these brackets, fill these brackets, and this is 4x.
So the limits of inner integral are y to 1 minus y, right, sir?
0 to 1 minus x.
0 to
y to 1 minus 1.
0 to 1 minus x.
0 to 1 minus x. Okay, I kept dx inside.
1 minus y it is.
0 to 1 minus y.
Yeah, 0 to 1 minus.
So first and foremost step is remove the inequality and keep it x plus y is equals to 1. So how will the x plus y is equals to line be? This is how it will be. And now I need x plus y should be less than 1. So this is x plus y equals to 1. And this will divide xy plane into two regions. One region will be x plus y greater than 1 and another region will be x plus y less than 1. Okay. So we need probability that x plus y is less than 1. So that means we need this region probability. So now this is a triangle. So this is a triangle with 0, 1 and 1, 0. Now you see how to compute the limits. So fix y. I said fix y. And once you fix y, you look at the limits of x now. So if that is y is fixed, I will have only a straight line. This straight line. And the limits of x. You see the limits of x. So how long it can take. So from 0, this is 0 anyway. From 0 till this line. So what is this line? X plus y is 1. So x plus y is 1 means x is 1 minus y.
1 minus y.
So x can go from 0 till x can go till 1 minus y. So the first inside limits will be 0 to 1 minus y. And after filling the inner limits, now you look at this y. So this y can go from 0 till 1.
To 1.
Okay. So
yes.
Then it will be 0 to 1. So these are the limits. Now you have to integrate it. That's it. So integrate it. You will get 2x square y 1 minus y 0. So you have to substitute this 1 minus y in place of x only.
Sir, will you please repeat that inner integral once?
Okay. So this inner integral is, so you fix y, some y.
Yes, sir.
So once you fix that y, so this is fixed now.
Yes, sir.
Okay. Once this is fixed, nothing else is there. Only this straight line will be there. Correct?
Yes, sir.
This straight line, you look at the limits of x. So from where to where x can go?
0 to.
So from 0 to
the point on the line.
Yes, point on the line.
Yes, sir.
Okay. So what is this point you have to identify? So from x is equals to 0 to, from x is equals to what?
To calculate x from that line equation.
So x is equals to till what? So that line equation is x plus y is equals to 1.
Yes, sir.
So from there you can find what is x.
Yes,
so x is basically 1 minus y.
Yes, sir.
So x can go from 0 to this what is nothing
y.
but equals to 1 minus y.
Yes, sir.
So that is what the limits, inside limits be.
Yes, sir.
And then outside limits are this
yes,
y.
Y will be from 0 to 1.
This y can be from 0 to 1.
On y axis.
Anything. Yes. So from there you just compute just put the limits. So
yes,
finding this limits is the difficult part. So how to find this is the difficult part. And yeah, this is how you should find. And I have this example with
Sir,
4, 5.
The limits of y are 0 to 1 because this function is valid only, by definition it is valid from 0 to 1, right? Right. Okay.
Why outer limit is not 0 to 1 minus x?
Why outer limit?
1 minus x.
We have fixed, right? We have fixed y. Okay. See, basically, you have to integrate this region. Okay, you want area, volume under this curve. Okay, in order to get volume, this is how we can do. So first, do along, you just add up along x. Then multiply it with y and then multiply it with fx to get the volume. Okay, so that is what we are going to do here. So we have fx inside, which is summing over, first of all we are summing it over x. So we are just multiplying, it's not summing, It's you are just multiplying this height into this length. So we are doing that area first. Then we are going to multiply the breadth, which gives us the volume under this curve 4xy. Okay. So outer limits are independent limits and inner limits are dependent on the outer limits. So one is independent and another is dependent. So you can treat it like that. So here I am treating y is independent of x now and x is dependent on y. So from there what I did is for particular y, I found out the limits of x in terms of y. Then that y can freely move from 0 to 1.
Okay. So in all integration, double integration problem, this will follow me.
You can follow this if you treat y as independent and x as dependent. And you can also do
otherwise means opposite
dy dx. In this case, you want to find the limits of y, you fix x. I will just explain that also. You fix x, you fix 1x. Okay, this is x. Once you fix that x, you find the limits of y. So for this x, the limits of y are from 0 to this line. So from y is equals to 0 to y is equals to something. So that something is nothing but y is equals to 1 minus x.
Yes,
so y limits are from 0 to 1 minus x.
X limits
So
are
this
from
will
0
be
to
0
1.
to 1 minus x. Yeah. Then x is this x is free
0
to
to
move
1.
from 0 to 1.
Yes, sir.
Okay. 0 to 1. dy dx. So this is dy dx. Okay. One trick or one remark you should always remember is whenever you are finding the limits for y, either it will be constant values or it is a function of x. Okay, here it will be 1 minus x or x square, or it will always be a function of x. Okay, you should never be like this 0 to 1 minus y something dy. Okay, you shouldn't get this. Okay, so the limits of y will always be either from constant to constant or it will be from function of x to function of x.
Other variable.
Other variable function only. So here also you can see if it is dx, the limits are from 0 to 1 minus y. So you should treat y as constant here. Okay, when you are computing integrals. Okay. Yeah, so I will upload this PDF. For the next class, just try to do this problem. Okay, do this particular problem. I have given four different kinds of probabilities. So each and every problem will be requiring that finding the limits first of all. Okay, firstly you have to find the value of k. That is the very first question, and then there are some 4 probability questions, regions, where you have to find the limits of both the integrals. So try doing this, then the other parts are very easy. Marginal density.
So in this question, fourth option, x is y to 2y. Fourth question.
X is y to 2y. So what is the probability that x is between y and 2y? Okay, if you wanted to take the screenshot right now, you can take it and try solving it now.
Yes, sir. Please show us.
You just take the screenshot and try it. For the next session, try to do all the 5 questions. Okay.
Would it be possible to have another session on, tomorrow or day after? I mean, Friday would be really late and 2 sessions are so less.
2 sessions are so less. If possible, we will try to have one more.
Yeah, okay. Please do. If not tomorrow,
tomorrow will be okay, sir.
Yeah, it would really make us. Yeah, if it's tomorrow, that will be best. But if not tomorrow, then day after.
Yes, sir.
Okay, we will try. We will try to have one more. So see, I am left with only this. The major part I am concerned about this limit only.
So we'll do more examples, sir.
We will do more examples in the next session also. But the other parts like marginal densities and the independence and the conditional, nothing to explain much. So same thing, same formulas works here.
Yeah, but then without you explaining, that won't make sense to us anyhow. So it would be really
Is it?
nice if we could do
Okay.
that, and also the
Okay.
examples on these limits.
Okay, we will try to have one more. But I will share this PDF. Before coming to the session, you just try to solve all the problems
Yes, sir.
Yes.
which are there in the PDF. Okay. If it is not possible, we cannot arrange because see, the schedules are very tight. There are some 18 or 19 courses are running at the same time. Okay, so we have to check for a possible time slot. If there is a time slot, we will definitely try to have one.
Sir, is the answer for the previous one, is it 1/6, sir?
This one is it?
That x plus y less than 1.
I didn't compute. Yeah,
Oh,
I have
okay,
to
okay.
compute.
Okay, sir. Next, in the next class.
What is it? 1/6? Did anyone solve it and got 1/6?
Yes, sir.
1/6 is correct.
Yes, sir.
Okay.
Okay. Thank you, sir.
Then it will be 1/6.
Yes, thank you.
Okay. Okay. Then it's been too late. We will end the session today.
Thank you.
Thank you,
Thank you
sir.
very much, sir.
Thank you. Thank you.
Thank you, sir.
Thank you, sir. Thank you so much.
Good night, all, and we
Good
will
night.
meet in the next session.
Good night, sir.
Yeah.
Good night.
Yeah. You will get this recording also. After I get the recording, I will upload. I will ask them to upload on the YouTube. Okay. Okay. Chalo. Bye. Bye. Bye all. Bye. Bye. Good night.
Good night.